All right, let's look at the examples of probability density functions. All right, there are two examples we're going to go over. First one is called the uniform probability density function, and the second one is an exponential probability density function. All right, so uniform probability density function is actually a constant function. So if it's defined on the interval from a to b, constant has to be 1 over b minus a. All right, let's check the two conditions. So obviously, you can see that f of x is non-negative, assuming that the b is larger than a, right? So this condition is satisfied, right? How about the second condition? All right, if you integrate from a to b of 1 over b minus a, right? And this is going to give you, so since this is the constant, you can kick the constant out, right? So I'm going to kick this constant outside the integral. So it's going to just sit there, 1 over b minus a, right? Then you have a 1 left. The antiderivative of 1 is x. And then you're going from a to b. Right, this is equal to 1 over b minus a, that's just a number, and plug in b minus plug in the a, and you can cancel out the b minus a on top and b minus a on the bottom, which gives you 1, which is the second condition we needed to satisfy. Right, so uniform probability density function is just simply 1 over b minus a. All right, so let's look at the second one, exponential probability density function. So f of x is equal to 1 over lambda. Lambda is any positive value, e to the negative x over lambda. And over the interval, infinitely long interval from 0 to infinity. All right, so you can see that if lambda is non-negative, the whole function is going to be non-negative. So the first condition is easily satisfied, and given that lambda is non-negative, so lambda is actually, maybe I should say positive, because we can't have 0 on the bottom. All right, and let's check the second condition. All right, so we need to integrate, so improper integral from 0 to infinity, 1 over lambda e to the negative x over lambda with respect to x. Right. First, we need to write it. I'm gonna actually pull out the 1 over lambda, so it's gonna come out. So 1 over lambda. All right. So since the improper integrals, I'm gonna use a limit as b approaches infinity. Then I'm going to replace the upper limit by b. Then you have a e to the negative x over lambda dx. All right, so we just have to compute this. So I'm going to take care of the limit later. All right, antiderivative e to the negative x over lambda would be e to the negative x over lambda. Right, divided by negative 1 over lambda is multiplied by negative lambda. All right, then you're going from 0 to b. All right, then if you plug in, so 1 over lambda, you have still have a limit. B approaches infinity. Plug in, oh, actually, before we do that, I'm going to do a simplification. So since there's a constant lambda here, and there's a lambda on the bottom, so I'm going to just go ahead and cancel it out. All right, that way it's nice and simple. All right, then if you plug in b, so you have a negative e to the negative b over lambda minus, it's negative, so plus e to the 0. So can I just write 1? E to the 0 is 1. All right, but as b approaches infinity, you have a e to the negative infinity. So this term is going to approach 0. So therefore, you're going to get 1, which we're supposed to get. All right, so this checks out. So therefore, 1 over lambda e to negative x over lambda, as long as x is a positive value, it is a probability density function. It is called the exponential probability density function. All right, that's it. I hope that this was clear.